Alright, we're working on the quadratics, the second quadratics test. First ones we're going to solve by the graph of the table. Solve, basically we're just looking for our zeros, our roots and solutions. They're, basically the same thing. We're looking where they cross the y-axis. So this crosses the y-axis there and there. This one over here, x equals -1. This one right here, x equals 2. This one crosses here and here. That's -4 and 2. When it comes to the table, we're looking to find where my y, the reason I call it zeros is because my y value is 0. So we're looking for this point and this point. I don't care about this 0 on the x. I really just don't care about it at all. So I want the corresponding x values that are associated with these zeros on this right side. So I want this -2 and I want this 3. Those are all my solutions there. Now I have these down here, the 4, 5, and 6. I'm not given a graph or a table, so I got to make those on my own with the graphing calculator. I'm going to go in here, clear out what's already in my calculator, and I'm going to type this in here. I want to know where it equals 0. So I have x squared minus 9, and I want to know where it crosses 0, also the origin, the x-axis. So I'm going to go to the table, and I'm going to find, see all this is 0? I just need to find my y1s where they hit 0. I see one there, and I found the other one there. So I care about -3, and what's the other one? 3. You could have written this x equals -3 and x equals 3. You could have also written that as x equals plus or minus 3. The second one, it's equal to -8. I can either move this -8 to the other side and set equal to 0, or since I'm using the calculator, I can just plug it in as it is. So I can insert a 2 in here, and 2x squared minus 10x, and that's going to equal -8. Go ahead, check the table, look and see where it crosses -8. I see one right there. It looks like the other one's below it. So I have 1 and 4. So x equals 1, x equals 4. And the last one here, we have this one here, finding where it equals 0 again. So I'm going to go 5x squared plus 55x equal to 0. There's one right there, and it looks like, so one's at 0, and the other one that looks like is at -11. So x equals -11, x equals 0. Those are my solutions there. Now we're going to factor these. I'm not going to factor all 6 of these for us, so I'm going to do 2 or 3 of them. Let's just go ahead and do this one right here first. If I'm factoring and I see a trinomial, I'm pretty sure I'm going to go ahead and use the box. When I use the box, I put my first term in here, so that's t squared, and this is 63. You know what? Alright, I'm actually going to do this on a separate sheet of paper so we can have a little bit more room. So this is number 8 we're working on here. We are going to do the box, and when we do the box, we're going to take the first term and put it here, t squared, 63 here. To find my peanut values, we're going to plug in a calculator. In y1, I'm going to take a times c and divide by x. So a in this case, number in front of the first variable, is 1. My c value is the last one, so that's plus 63, divided by x. My y2 value is going to be a times c divided by x plus x. So 1 times 63 divided by x, and then I'm just going to add a plus x on the end. I plugged that in the calculator just exactly as I see it there. So y equals 1 times 63 divided by x over 1 times 63 divided by x plus x. Now look at my table. In my table, I'm going to look for b down here. And b in this case is going to be this negative 16. It's going to be this negative 16. So I look at my calculator, I'm looking to the right, I see negative 16, and I get negative 9 and negative 7. If you look, you actually see the 16 twice. And it has negative 7, negative 9. Those are the same two numbers. It doesn't matter, they're interchangeable. Negative 9, negative 7. So we have negative 9, negative 7. Now I'm going to take these two values, negative 9x, and then negative 7. Well, I guess in this case t, like that. Once I have those values in place, I can go ahead and do the greatest common factor right here. They don't have any part of the numbers in common. Nothing in their numbers matches. So the only thing they have in common is the t. Then I can go ahead and look t right here times what number gets us t squared. That's going to be t. Then t times what number over here is going to get me negative 9t. That's going to be negative 9. Then I switch back up here. T times what number is going to get me negative 7t. That's going to be negative 7 here. And then I can check to make sure I did that right. Negative 7 times negative 9 is 63. Those are good values. So my factored form for this is t minus 7 times t minus 9. That's number 8. So that's going to be t minus 7, t minus 9. Alright, let's look at another one. Let me pick something a little bit easier. Let's look at number 11. 3j squared minus 27j. There's no third term here. This makes it a little bit easier for us because they both have a j. Since there's no third term and they both have a j, I can factor that j out. I know they both have a j in common, so I'm going to pull that out. What about the numbers? Do 3 and 27 have a j in common? Yeah, both of them are divisible by 3. So 3j times j gets us 3j squared. And then 3j times negative 9 gets us negative 27j. So this is my factored form. That's all we need to do for this one. That's my factored form. 3j times j minus 9. Alright, let's go switch over and do number 12. Number 12 is just like number 8 that we did earlier, except it has a little bit bigger numbers. So it is, let's go ahead and fix up my box. 2b squared goes here, 21 goes there. Shouldn't have any problems with that. Now we're going to use the calculator. Okay, my a value instead of 1 is now 2, so I'm just going to change that directly in my calculator. My c value was 63, now it's going to be 21. Go ahead and change that one. That's all I need to change in here. Change it for the second line too. Look at my table. Instead of looking for a negative 16, I'm going to look for positive 17. Don't see if I put that in right. 2, 21. Alright, I finally found it. Looking for positive 17. It's right here with 3 and 14. It's at 17. Again, don't forget that it'll probably show up twice. If I keep going again, here it is, 14 and 3. So they're the same numbers, but it might show up twice because they just switched them around. So we have 3 and 14. So I'm going to go with 3B and 14B. Once I have my box complete, I'm going to go ahead and take my greatest common factor right here. 2 and 3 have nothing in common, but they both have a B. And look now, B times what number gives me 2B? So that's going to be 2B, so sorry, 2B squared there. Multiply that by 3, multiply that by 7. Make sure I did it right. 7 times 3 is 21. Yep, I'm good for that. So that's my factors here. I'm going to have 2B plus 3 and B plus 7. That's it for 12. 2B plus 3, B plus 7. Now we're going to switch over and do some word problems. Word problems here, number 13. It says the area of a rectangle. The area of a rectangle is this and has a width of x squared. In terms of x, what is the length of the rectangle and what's its perimeter? So I'm going to go ahead and I'm going to draw this out. I'm going to go ahead and draw this out. I have a rectangle, and I'm going to draw the area inside. My area is x squared plus 11x plus 18. And it says my width of my rectangle is x plus 2. So what I need to do to find this length over here is I need the length before I can find my perimeter. Is I need to factor x squared plus 11x plus 18. And when I factor that out, I'm not going to factor the squares, we just did factoring up here. When I factor that out, this is going to get me, well, let me go ahead and let me do this one. We worry about not doing the next ones. So my calculator, I'm going to go in here. My A value is 1, and my A value is 1, and my C value is 18 divided by x, and change this one, 18, and I am looking for 11, and we have 9 and 2, 9x, 2x, x in common there, x times that, 9, 2, that's 18. So you can see here my factors are x plus 2, x plus 9. So I'm going to use this x plus 9 as my length there. Those are my dimensions there. So my length here is going to be this x plus 9. Now when we find the perimeter, I have to make sure I include all my sides. When I find my perimeter, I need to use all my sides. So I have 4 x's, and then I have 9, 2, 9, 2. So that's 11 plus another 11 is 22. That is my perimeter here. My perimeter is 4x plus 22. Oh, y'all can't see that at all here, can y'all? It's a bad color. my x's here, here, and here. That's how I get my 4x. And then 9 plus 2 plus 9 plus 2 is 22. Alright, let's look at 14. Alright, 14, we had find out length, width, and perimeter. 14, 15, 16, they're all basically the same. Only difference between 15 over here is it's a square. So both the sides are going to be the same, done the same way. Probably a little bit simpler because of that. So for 14, a rectangle, find its length, width, and perimeter. So we're going to have to take the factors of that. When I factor this, I'm going to have to use the box and all that. And I factor this, so this is 14, I'm going to get x minus 18 and x minus 12. Those are the factors I'm going to get. I'm not going to go through doing the box again. I've done it 3 and 4 times already. So there's my length and width. So for my length, I can pick one. I don't care what it is. Length and width are interchangeable. X minus 18. My width is going to be x minus 12. Now if I want to find my perimeter, why don't we go ahead and draw a picture of this rectangle. Length is going to be x minus 12, x minus 18 here. Go ahead and take it down here, 12, 18 there. Go ahead and count my x's, 1, 2, 3, 4 x's, so that's 4x. Negative 18, minus 12, minus 18, minus 12, minus 60. There's my perimeter. 4x minus 60. Okay, I'll leave 15 and 16 for y'all to figure out on those own. Now we're going to look at solve the following by factoring. Solve the following by factoring. I'm going to go ahead and do, I'm only going to do 1 or 2 of these because it's just factoring plus one little step. Factoring plus one little step here. Let's go ahead and take the easiest one up front. So 17. For 17, I have to make sure it's set equal to 0. X squared plus x, and I'm going to take this 2 and move it to the left. That means it's going to become a negative 2, and all that's left over there is nothing, which is 0. Go ahead and box it up. X squared minus 2. If I put that in a calculator, I will get, what do I get this? Well, let's go ahead and do it. 1, this will be negative 2, negative 2, and I'm looking for 1. The number in front of the x is a 1. So where do I see a 1? There it is. 2 and negative 1. 2 and negative 1. 2 and negative 1 there. Oh, x. So this has an x in common. X, 2, negative 1. Does that work? Negative 1 times 2. Negative 2. Yes, that works. So my factors here, x minus 1 and x plus 2 equal to 0. That's my factored form. After I do this, I split this and say x minus 1 equals 0, x plus 2 equals 0. Add 1, x equals 1. Here I subtract 2, x equals negative 2. Those are my solutions there. My solutions here are x equals 1, x equals negative 2. Let's do one more slightly harder one. Let's go ahead and just do 20. 20. We have 8s squared. So my 8s squared, and I have an s squared over here. So I'm going to subtract 7s squared, and I get simply s squared plus 3s plus 2 equals 0. There's my trinomial. I'm going to go ahead and factor it. When I factor it, s squared, 22 there, and I'm going to look for 3. So back to my trusty calculator, and my a value is 1 again. Then I have 22, and I can go ahead and look at the table, and I'm looking for 3. That doesn't look good. Oops, that's not 22, that's just 2 equals. My mistake. And my table, and I'm looking for 3 again. Okay, 3. There it is, 2 and 1. 2x, 1x, and from here I have x because, s, 2, 1, this was supposed to be a 2, so that works. So I have s plus 2, s plus 1 is equal to 0 now. So s plus 2 equals 0, s plus 1 equals 0. So this is negative 2 and this is negative 1. So x equals negative 2, x equals negative 1. And the last 4, I'm going to do 1 or 2, I'm going to do probably 23 and 24. It's something some of us have not done in class, so this is the first time y'all are going to be seeing it. We're just working backwards. We're just going from my solutions, like we've been getting here and here, and we're going straight to what we'd call factored form. Factored form looks like this right here, or this, and from there we'd set equal to 0. This is all you have to do to make this go back to factored form. I want you to put your parentheses. That's where we're going in factored form like this. We notice typically start off with the x. And what will this have to be? Just kind of reverse our numbers here, make that plus 2, make that minus 8. Because if I solve this, if I solve this x plus 2 is equal to 0, and this x minus 8 equal to 0, and that part of it, that's how I would get, let's see how to subtract 2. Subtract 2, x equals negative 2. Add 8 over here, x equals 8. So there's that negative 2 and 8 that we got earlier. So we're working backwards. We're doing this step in reverse. And these 23 would be x minus 5, x plus 6. Just turning them around. If it was a fraction, it might be a little bit harder, but I don't think you're going to see that. And 26, we've covered these with figures in class multiple times, so I think we've done this problem 4 different times in class with a diagram. This is the one where we have x and we're adding c, x and we're adding c, and I want the value of these out here. So, well, let me just go ahead and finish that. So this is x squared, this is cx, cx, and c squared. I don't want this one, I just want these 3 over here. So I have 2 cx's plus my c squared. That's the area of this part of my rectangle. And again, the one you're going to see on the test, like the ones you've seen in class, this area is going to be shaded, and they want the white area outside, the bigger rectangle. So it's this minus that, so I just take that one off.